Hello everyone, my name is Shruti Bhaikar and I am from TYD Tech Civil Engineering. So today we will learn about the concept of bridges in civil engineering. So the bridges are one of the most essential and iconic structure in a civil engineering, and they are built to span the physical obstructions like river, valleys, roads, or railways, which provide a smooth and uninterrupted path for transportation and communication. So bridges are not only facilitate the movement of people and goods, but also they plays a significant role in economic development and regional connectivity. So now we will talk about the classification of bridges and their components. So in a classification, they are based on various types like function, structure, and also the material. So the first is the classification by function. In this first is aqueduct. Now one aqueduct is a bridge, especially which is made to carry a water across a gap such as valley or a road. And in a historical time, it is used as a civilization aqueduct at a time, and they are still now used in a today as an irrigation system. So these are the Roman aqueducts or modern concrete water channel. And second one is highway. So the highway bridges are designed to carry a vehicular traffic such as car, buses, and trucks, etc. And they are just most common type of bridges which were found on a national highway, express highway, or a rural roads. So for that example is flyover and overpass in a cities which is constructed in a various ways. Next one is a railway bridge. So it is especially built for the train, and these bridges must handle a very high loads and vibration, which is caused by a fast moving trains. And the special care is taken in their design to ensure the strength, stability, and long term durability. Then we will talk about the pedestrian. So pedestrian bridges are just meant only for people for walking or used for a light mode transport like bicycles or etc. And these bridges are usually a lighter in a structure and also often found in a parks like near schools or over any bus roads. So the example of this is like skywalk in urban areas or like park or bridges. Now we will classify by structure. So the first one is beam bridge. Now it is the most simplest type of bridge which is consist of horizontal beam and it is supported at the both end by piers or abutment and the load is transferred directly downward. So it is mostly suitable for the short span, like example highway overpasses. Then we will talk about the arc bridges. So it is shaped like actually shaped like an arc, and it will be with the load being carried outward along the curve to the support. So it is a very strong and durable, and it is used for a medium span. So they were commonly made of the stone in an ancient time, and now it will be built with a concrete or a steel. Then we will talk about the truss bridges. So it is a composed of a framework or a triangular unit, and it is very efficient in a distribution load, and it will be suitable for a longer span. It may be often made up of steel also. And now these railway bridges are commonly seen on a highways. Then we will talk about the suspension bridge. So the deck or roadway, which is hung below the cable that are suspended from the tall towers, and it is mostly suitable for a long span. So especially it is overloaded by the river or bays are there. And the example is Golden Gate Bridge in a USA. Now we will talk about the cable stayed. So cable stayed bridge is like similar to the suspension bridge, but the cables are directly connected to the tower instead of being suspended over them. And the more modern and efficient use for this medium is to for the longer span. Now the example is Bandra Worli Sea Link in Mumbai. Now we will talk about the primary component. So it is Basically, the consist of superstructure, substructure, and foundation. So the bridge is usually made up of several key components that works together to carry a safe load and transfer them to the ground. So these components are generally classified in a main parts. Now talking about the superstructure, it is the upper portion of the bridge, and this is directly receives and supports the live load like vehicle load, pedestrian walking load, or etc. And it will includes deck like surface on which we will moves or the traffic will move. Then trusses or arcs, girders or beam, like bearings. And the main function is it will transfer the load to the substructure. Now the substructure is consist of what piers, abutment, wings wall. Now what is substructure is? So it is an intermediate part between the superstructure and the foundation, and the supports the structure and transmit the load to the foundation. So the pier is basically a vertical support in the middle of the span, and it will provide a vertical support and stability. Then the foundation is the lowest part of the bridge structure, and they are embedded in a soil or a rock, and they carry the load from the substructure to the ground. Now, this foundation is also having various type, but basically they are using a shallow foundation or deep foundation, and the basic function is like they will distribute a load safely into the earth. Now, while constructing the bridge, why they are think about the economical span or site selection. So first of all, the economical span concept is like they will balancing the superstructure and substructure. So it will be efficient for cost or also efficient for the costing the design. Talking about the influencing factors, so they are consisting of site conditions like material prices and construction methods, impacts, and span choices. While selecting a site, they are generally based on geology, hydrology, and excesses of effective placements. So, as we know, the water plays a major role in a safety and stability of bridges, and especially those built over a rivers or stream. So, it's very important for civil engineering to study a hydraulic factor before designing the bridge. So, we will look out for the afflux first. So, afflux is the rise in a water level upstream of a bridge due to the obstruction, and it is created by piers or abutment. So, if afflux is too high, it can leads to flooding, and that's why the engineer must calculate its accuracy or accurately and design, and it will be proper water opening. Then we will talk about HFL. Now, HFL is high flood level. So, the maximum height which water reaches during a flood is HFL. Now, knowing about the HFL, it helps to decide how much vertical clearance should be provided between the water surfaces and the bridges deck to avoid the submarine bridges. Now we will talk about the score depth. So the score depth is what is it will be the depth of soil erosion around bridge, and it is a foundation which is caused by fast flowing water. So this is very dangerous because it can expose or weaken the foundation. So we will estimate the maximum expected score or a depth and design, and it will be the deep enough foundation to resist it. Now we will talk about the loads which is impacting on a breach, and it will definitely by RC board specification. So the breach experience various loads, and it will like dead load, live load, or wind load, or seismic load. So dead load is what about? It is self-weight of structure. Then live load is vehicles load or pedestrian walking load. Also the impact of wind, seismic and temperature load. So the Indian Roads Congress, like IRC, is classified this load into the classes like class AA or class A or class B, which is based on the vehicle weight and type. Now, talking about the load combination, so while designing a bridge, it involves combining multiple load safety. For example, live load plus wind load plus impact load may be considered together, and the proper combination is help to ensure a reliability and prevent overloading or a failure. So these are the case studies which shows the failure of bridges in India. So the common cause is design flaws, construction error, poor maintenance, and natural disaster. So we will understand a real case which helps us to learn and improve the future design. So the first case study is bridge collapse due to the foundation score and insufficient inspections. So in this case, a bridge is collapsed due to the score at a foundation, and there is a lack of timely inspection. So the highlights which is important in a site, and it is analyzed and regular monitoring area. Second case study is of structural failure from overloading and substandard materials use. So like here is a bridge which is failed because of overloading and use of poor quality materials. So this shows how strict quality control is essential during construction. So the lesson learned is that from this failure we learn like updated design codes or regular maintenance is necessary or regular inspection is necessary, and which type of quality materials we are used, and they are specifically uh, there be a safety or durability while constructing the bridges. So now what we will conclude from this topic is that bridge which we will constructed is sustainable. It should be a safe bridge or infrastructure. So while constructing any bridge, it maybe take a precaution like it will be a eco-friendly material or it will minimize the environmental impact. Also, there will be a regular maintenance while checking after a year or after the time. There will be a ensure of safety through the inspection and timely repairs. And talking about the future trends, so a smart while constructing the bridge, there should be a take care by an engineer to make a smart bridges. Like it will be the innovative material, or it will improve the longevity or performance. So these small things are making the work easier, and it will be more like smart technological like sensors. So this will help to build a long lasting and safe bridges for the future scope. So I hope you will understand from this topic, and that's it. Thank you.